Hi everyone, let's talk about a collection of results that I like to call the power divisibility lemmas. These are some lemmas that are pretty useful in math contests and olympiads, but they're often not stated explicitly enough. So today I'm going to be showing you what those lemmas are. I'm just going to be listing them out without proof, and I'll leave the proofs to you. So we'll let A, B, and C and M and N be positive integers. So positive integers. What we're going to do is we're just going to run through the lemmas. So let's go right into the first one. There's going to be a bit of notation, but I'll explain it right after. So A is equal to b to the power of n. So A is an nth power. A is an nth power if and only if for every prime n divides nu p of A. Now you might be wondering what this notation means, and it's very simple. So you look at the prime factorization of A. Let's say A is equal to P1E1, P2E2, all the way through to PKEK. And so what we say is that nu Pi of A is equal to EI. So this is just the multiplicity of the prime Pi in the prime factorization of A. So this is nu P1A, this is nu P2A, and all the way through to nu PK. Sorry, nu PK. So essentially what we're saying in the first power divisibility lemma is that A is an nth power if and only if the multiplicity of every prime in its prime factorization is a multiple of n. Let's go to the second power divisibility lemma. The second one says if P is prime and P divides A to the power of n, then P to the power of n divides A to the power of n. This is pretty important because instead of just getting P dividing A to the power of n once, you can jump to saying P to the power of n divides A to the power of n. So P divides A to the power of n times. Intuitively it should be true, but it does require proof, and I'll leave that to you. Let's go to the third power divisibility lemma. By the way, there's 6 of them. The third one says that if GCD of A and B is equal to 1, then GCD of A to the n, B to the m is equal to 1. And this should make sense because the GCD of A to the 1, A and B is equal to 1 if and only if they don't share any prime factors. But that's going to be the same for A to the n and B to the m, because taking them to the power of n and m does not add any prime factors. The fourth power divisibility lemma is very interesting and powerful. It says that if A to the n is equal to B to the m and GCD of n and m is equal to 1, then first of all, notice that A to the n is an nth power, but we can say that A is an mth power. So A is equal to C to the m for some integer m, some integer C. And B is symmetrically is an nth power. So B is equal to D to the n for some integer D. We can take C and D to be positive since A and B are positive. The fifth power divisibility lemma says that if c to the n is equal to a times b, and GCD of AB is equal to 1, then A and B are each individually nth powers. So A is equal to some, let's say, x to the power of n, and B is equal to some y to the power of n for positive integers x and y. So like this n splits, well, it distributes over a and b in a sense. And finally we have the sixth power divisibility lemma, which says that a to the n divides b to the n if and only if a divides b. So we can either go from nth powers to just a and b, or we can go from a and b to nth powers. So those are the power divisibility lemmas, very useful in contests and Olympiads, and I hope they serve you as well as they serve me. Thanks for watching. I'll see you next time.